Good evening, students. Today we will discuss a meter in circuit and the meter out circuit. Now, this meter in and meter out circuit are used for controlling the speed of a cylinder. Now, first we will see the application, and depending upon the application, we will see what is the necessity of this meter in, meter out, bleed off circuit, regenerative circuit. Now, sometime we need a faster speed of a consider the example of drilling machine. Now in a drilling operation, while drilling operation is taking place, at that time the speed should be a lower one, and retraction means backward motion of the drill bit can be a faster one. Now this drill bit is attached to a piston rod. Now if I am controlling the speed of a piston rod, means now we are controlling the speed of actuator, and that is the requirement of the speed control. Now so various speed control circuits are there. Now we will see the meter in circuit. Now in a previous lecture we have already seen that how what are the various component of a hydraulic circuit. Now we will begin with the component. Now here always we begin with the reservoir. Now reservoir, it is at the bottom. Now here there are two circuit. Now we will see the speed control when speed advances first, and then in the reverse direction speed is not controlled, that we will see. Now I will zoom out. Now here, now begin with the reservoir. Now from the reservoir, pump is pumping the oil. Now motor is driving the pump, so pump is pumping the pressurized oil. If the excessive pressure is there, then pressure relief valve is bypassing the oil to the reservoir. But if the pressure is below the preset value, then this pressurized fluid is going inside the 4 by 2 direction control valve. Why this is called as 4 by 2 direction control valve? 4 it is there for the 4 ports. 1 2 3 4 pump. Then I will show in the another diagram. I have handwritten diagram. Now here meter in circuit. Now here PT. Now this P stands for pump port, T stands for tank port, A stands for A side of actuator, B stands for B side of a actuator. Once back to the this diagram. Now here, now this is the 4 by 2 solenoid operated actuator. Now here from the pump, the fluid is pumped and it is direction control valve. Now position number 1 is there. Now from the position number 1, fluid is going inside the flow control valve. Now it is not going inside the check valve. Now check valve, you can see the arrow of the check valve. Now check valve arrow is upward. Now the flow occur inside the check valve in the reverse direction that of the arrow. Now here check valve direction is upward, so flow should be from the upside to a downside. Now here pressurized fluid is available at the bottom side, so there should not be any flow from the check valve. So all the flow is occurring through the flow control valve. Now through the flow control valve, metered quantity is given to the A side of a cylinder. So our aim to have a speed control when piston advances. When piston is moving in the forward direction, at that time only we need to have a speed control. So now metered quantity, lesser quantity is given to the A side of a cylinder, so we are having a lesser speed when it is having a forward stroke. And whatever the fluid which is present in the B side, that is given, that is connected to the tank through a filter line, and it is given to the reservoir. So we are having a lesser speed in a forward direction. Now we will see the what about the return stroke. Now for the return stroke, this is the diagram. Now for the return stroke, we need to change the position. Now here you can see the position number 1 is there. Now here in a position number 2, now pump P is connected to a B side and then A is connected to a T side. So now what will happen? Pump is pumping the fluid. Now pressure relief valve, it is in the off condition. It is a generally normally off condition. So fluid is going through a B side. So all the fluid is going in the B side. So piston moves in the leftward direction. Now let us check whether speed is fast or slow. Now from the A side, when fluid is there, that fluid, it is now having a two ways, either through flow control valve or through check valve. Now check valve is open. Yes, So check wall is bypassing all the fluid to the tank through a filter. So all the fluid without metered quantity, all the fluid is going inside the reservoir. So in a reverse stroke we are getting a higher speed. So we can now see parallelly both the diagram. In a forward stroke we are having a metered quantity. So now that is why it is called as a meter in circuit. Metered quantity is given to the for the stroke. Now this is precisely, this is generally it is written meter in circuit, but this is meter in circuit for the extension stroke, for the forward stroke. This is the meter in circuit for the forward stroke. Now this is the fundamental. Okay, now and in a return stroke it is a faster one. Now there can be a meter in circuit for the retraction also. Now I have handwritten diagram for the meter in circuit for the retraction. Now left hand figure, same figure is there, meter in circuit for the extension. Now here same thing is there, pump is pumping the fluid. Now P to A, from the A there are two ways, but check wall is in a closed condition. So to flow control, just I am explaining the same diagram, left hand side diagram. Flow is occurring through flow control wall, so metered quantity is there. So extension stroke, meter in circuit for the extension, this is the thing. Now same thing can be there for the meter in circuit for the retraction. Now sometime there can be a application where we need a limited speed in a reverse direction. So now here let us check, pump is pumping the fluid. Now through A side, meter in circuit is there. So now here meter in circuit it is giving the supply. Now here now we want to control the meter in circuit for the retraction. So now it should be in a position number 2. Now in a position number 2 pump, now here I have in a diagram right now it is in the position number 1, so it should be in a position number 2. So now pump is pumping from P to B. Now B metered quantity is given, and then we are having a retraction stroke, and retraction stroke it is having a lesser speed in a retraction. Now in a position number 1, now right now whatever the diagram is there, now what will happen, from the P to A, supply is going inside the cylinder. In the outward side whatever the fluid is there, there is no restriction, so all the fluid is bypassed to the cylinder. So fast stroke in a forward direction, and the meter in a retraction stroke metered quantity is given. So now this is the meter in circuit for the retraction. Now we will see for the what for the meter out circuit. Now meter out circuit for the extension. Now we'll see the left hand side diagram. Now here pump is there which is attached with the motor, pressure relief valve is there, line is directly bypassing the fluid to the reservoir. Now here from the P port it is supply is given to the A side. Left hand, I am explaining the left hand side diagram. Now here supply is given to the A side, and now whatever the fluid which is present on a B side, now again it is having a two-way. One is through the one is through flow control wall, and another is through check wall. But now here check wall is in the closed condition, so metered quantity is given out. So it is called as the meter out circuit. Metered quantity is given out to the reservoir through a filter. So now here meter out circuit for extension. Extension stroke circuit, in extension stroke speed is controlled by using meter out thing. Okay, and now in a reverse stroke, now here see the left hand side diagram only. Now here we can switch to the position number 2. Now in a position number 2 P is connected to a B side. Now here B side, if it is connected to a B side, the flow is occurring through check wall, so there is a faster retraction stroke, and now whatever the fluid which is present on A side it is given to the tank through a filter. Okay, so this is the meter out circuit for the extension. Now similarly there can be a meter out circuit for the retraction also. Now here in a retraction stroke, now again consider the position number, it is in the position number 2. Now first position or PTAB it is written, this one is the one position, and or cross symbol it is the position number 2. So P is connected to B, and now this supply from the B, it is pushing the piston towards the leftward side, and the whatever the fluid which is present, now it is given to, and it is now having a two ways. Now here check valve is in the closed condition, so all the fluid is flowing through a flow control valve. So now here retraction, for the retraction outlet quantity is metered, so it is meter out circuit for the retraction. So this is the meter out circuit for the extension and meter out circuit for the retraction. Now this is the, these are the just remember in an exam, just remember only one circuit for the extension, meter out circuit for the extension, and the meter in circuit for the extension, only just to avoid the confusion, because in some book, I think in a one Nirali book, the meter out circuit diagram is wrongly given. So just remember only meter in circuit for the extension and the meter out circuit for the extension. Both these two diagrams are sufficient for the writing to write in the exam. Okay, so now this is for the, that's it for the meter in and meter out circuit. For the other circuit I will make a separate video. Okay, if you have any doubt, you can raise over the WhatsApp, you can personally WhatsApp me. If you have any doubt, I will you can send me a image, whatever, if you have any problems, then you can send me image. I can make a video on that image. I do not have any laptop right now, so I will make the image on the mobile and I will send it on the WhatsApp. You can, I will send it personally, or I can send it on the group also. Okay, that's it for my, from my side. Thank you very much.